When the simulation has been successfully completed, the result page opens, which, by default, shows the results of nominal operating conditions first. The first line contains an evaluation of the results. All temperatures at nominal and overload conditions are taken into account for the evaluation. It monitors whether critical temperature limits are exceeded. Below, you find the circuit efficiency at nominal conditions and the losses of the entire circuit. Losses per heatsink are also included in case only part of the simulated circuit is mounted to a single heatsink. Links to save the results are activated after finishing a simulation. You can save the simulation input in your private account in the cloud, or as a file on your hard drive. Only the input of the session is stored, but not the results. If you load the file later, the simulation must be started again. The data input and the results can be saved as a simulation report as a PDF. The presentation of the results for the individual switches in the circuit varies depending on which circuit you have selected. In this example, we have chosen a 2-level, 3-phase inverter with IGBTs. The T indicates the transistors, while D indicates the freewheeling diodes. The temperatures from the heatsink up to the maximum junction temperature are shown on the right-hand side. The losses per switch are also shown on the right, showing the proportions for conduction and switching losses. Below the bar diagram, you find the graphs of temperatures and losses for one period of the output frequency. The diagrams are given in 360 degrees of a sine function. If the resolution in the y direction is too low, you can turn off the 150 degrees C limit for the critical temperature range. You can activate and deactivate each function by clicking on the icon in the legend. The maximum and minimum of temperature swings are indicated as Tj max and Tj min in the bar diagram. The data used for the diagram may be copied to the clipboard where the link shown here. The same graphs for the freewheeling diodes are shown below the IGBT. The power dissipation of the diode has a unique shape which may look strange at first, but this shape is caused by the pulse width modulation and the different conduction time of the diode within the period. The function values may be seen if you move the mouse over one of the graphs in the diagram.